Alright, graphing functions now, and your learning target is I can graph functions given a specific domain or domain including all real numbers. Alright, your key concept here is in order to graph functions given a domain, the first thing you're going to want to do is evaluate the function at least 5 different values of x. Okay, that first blank is 5 different values, 5. Okay. Second thing is you're going to want to plot those points on a graph and see if you can see the pattern. If a pattern is unable to be seen, then more points may need to be used. You may need to evaluate at more than just those 5 different values of x. Okay. And lastly, if you can see that pattern, you see how it is going. The third step here is to connect the points with a line or curve. Okay, so those second and third blanks are line or curve. Okay, example 1 asks us to graph the function x minus 3y equals negative 6 for the domain negative 3, 0, 3, and 6. So what that means is we need to find out what is the value of y for all of these x domains. Okay, so let's do that first. Let's evaluate all those when x is negative 3, 0, 3, and 6. So we're going to have x, and we're going to build kind of a little table here. And our function is x minus 3, y equals negative 6. And then finally what our y is. So you're going to build this function, and we're going to evaluate when x is negative 3, 0, 3, and 6. And so what that means for all of these is that instead of x, we're going to write whatever these are. Okay, so negative 3 minus 3y equals negative 6. 0 minus 3y equals negative 6. 3 minus 3y equals negative 6. And finally 6 minus 3y equals negative 6. Alright, now we have to figure out what is y really equal to given these equations here. And so let's rewrite the first one down below here. We have negative 3 minus 3y equals negative 6. We're just solving it like we normally would. We have to add 3 to both sides. So that's a negative 6. And we get negative 3y is equal to negative 3. Divide by negative 3. And we end up getting y is equal to 1. So 1 goes right up there. Okay, now let's do the same thing, except we're going to solve for when x is equal to 0. And I'm going to move this down real quick. So now it's going to be a 0 minus 3y is equal to negative 6. All we have to do here is divide by a negative 3. And we see that we get y is equal to 2. So go back up to your table here, and we're going to put a 2. Now do the same thing, but now x is equal to 3, so we get 3 minus 3y equals negative 6. Subtract 3 from both sides. Negative 3y equals negative 9. Divide by a negative 3 on both sides. And we get y is equal to 3. And we can see a pattern is being made here that every time we put in an x, we end up getting one step further, right? So this last one should, in my mind, be a positive 4. And if we do that, we'll see, once we divide by a negative 3 on both sides, that we get y is equal to 4, which is true. Okay, so now let's build a graph and actually graph these points on the coordinate plane. Okay. Now when we design this graph, we need to make sure that we have all of our x's and all of our y's, and we need to be able to see those. So let's go ahead, and we're going to make just a horizontal line. And we know this is going to be our domain. We need to have from negative 3, 0, 3, and 6. So let's start at negative 4 here. Negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, and I'm going to run out of room, looks like, to 6. I'll put in all those points. Okay, and then we need to do a vertical line, and the vertical line just needs to have positive 1, 2, 3, and 4. Okay, so really we don't have to do much here. We're just going to have 1, 2, 3, and 4. And we see that when x is negative 3, y is 1. So we can put a dot there. When x is 0, y is 2. When x is 3, y is 3. And when x is 6, y is 4. Okay? And that's all we're asked to do, is just graph the function at those specific points. And so we've done that. Okay, example 2 says use this graph here of the function f of x equals negative 1/2 x plus 4 to find the value of f of x when x is negative 4. So all we're trying to do is evaluate, using this graph, when f is negative 4, what is the value of y? So we go over to x negative 4, which is right here, negative 1, negative 2, negative 3, negative 4. And we can see it meets the line at this point of y, and y at that point is at here. So 1, 2, 3, 4, 5, 6. So the f of negative 4 then would just be a positive 6. Okay, example 3 says a mouse can run 3.5 meters per second. The function y equals 3.5x describes the distance in meters the mouse can run in x seconds. Graph the function. Use the graph to estimate how many meters a mouse can run in 2.5 seconds. So all we're doing is we're taking this situation, this scenario here, and we're going to make a graph out of it. And so let's pause the video and do that real quick. So I've built a graph, and yours should be something like this as well, where you have a y-axis of from 0 to 16, or something like that, just trying to get a good range of amounts, and the distances in meters, and then our time in seconds. And remember, when I said when you build a graph, you want to evaluate a graph at least 5 locations, okay? And so I've built 5 locations, 0, 1, 2, 3, and 4 seconds. And so what we're going to do is we're going to plot this graph onto based on what all of these are equal to. And so the easiest way to do that is to use our calculator. So get your calculator out, and we can plot or plug in the equation, which is y equals 3.5x. And if we go to the table, let's first go to table set, second window, and we want it to start at 0, and we want it to go up every 1, okay? And if you press second, then graph now, it'll tell you exactly what those values are. When x is 0, y is 0. So we can go ahead and plot those points on here. When x is 0, y is 0, and I've got a little dot here at the origin. When x is 1, y is 3.5. So let's go ahead and put that right about there. When x is 2, y is 7. When x is 3, I'm just going to let you guys in on the secret, y is 10.5. And when x is 4, y is 14. About right here. Okay. Now it's asking us to graph the function. Okay. So this is going to end up being a line. Okay. So you want to take your straight edge, and we're going to want to connect all of these dots here. And we can see that there is a little bit of human error here. We're off by a little bit. But it does follow the same line, or at least close to the same line here. And then there was a second part of the question. It said use the graph to estimate how many meters a mouse can run in 2.5 seconds. 2.5 seconds is at this point right here, and if we do go straight up from 2.5 seconds, and we build a 90-degree angle right there and go as far over as we can, we're going to see that, you know, it's a guess, but it's going to be somewhere, and I can even do this too, so I'm a little high. It's going to be somewhere around 9 meters. So let's just say then, for our function evaluated at 2.5 seconds, it is equal to 9 meters. And we're going to put this a little about symbol because we're not exactly sure the exact location, because when we look at a graph, we can never be absolutely positive. there's going to be a little bit of human error and just not being able to see it perfectly. But it's going to be somewhere around 9.